All right, students, we know from earlier lessons that Newton's universal law of gravitation, Newton's law of universal gravitation states that when you have masses, two bodies of masses, they attract each other, and that force they attract each other is called a gravitational force, and it is proportional. What it means is that when the masses are greater, the forces between the gravitational pull is also greater and inversely proportional to the square of their distances. That is when they are far separated, the forces become weak. That is the meaning of the law. So how do we represent it mathematically? So we are saying that what we are saying is that F, let me use different color. I'm using blue. F is directly proportional to the masses in the product, and the same F is inversely proportional to R squared. So when I put the two together, I'll get this. Is that clear? And after every variation, we have an equal to and a constant. As I said, we said in Form 1. And here, the constant we introduce is the chain. And the chain is called our universal gravitational constant. Is that clear? So we said that the forces, they are equal and opposite, and they attract each other. That is what we have there. Okay, good. So let us continue with this idea. How does this help us? This is what I have said. So I have shown you the meaning of the chain. So read it one by one. Where G is what? The constant of proportionality. And we call it what? Universal gravitation what? Constant. Then the F is called what? The attractive force, or the what? The gravitational force. Or you can say gravity. Then the masses. And you have to also take notice of the unit of the bodies involved, the parameters in the equation. The mass should be in kilograms, the R should be in meters, and obviously your force should be in newtons. I said this one earlier when I was defining the law. When the particles are farther, the force is weak. And the particles, when they are closer, the force is great. So when do you have the greatest gravity or the greatest gravitational force? It's when the bodies are in contact. When the bodies are in contact, you have the greatest gravitational force, or the greatest gravity, or the greatest attractive force. Please, are we here? Good. But if someone didn't ask a question, how about this gene? Say, how about the gene? The unit in the then say you have told us the unit of force, that of mass, and R. How about the gene? We can derive the unit for gene. How do we derive it? I gave it to you as assignment last time. But let's see if we can do something with it. You know this formula. Over what? R squared. Sorry. R squared. So let's try and make change the subject. What do? We multiply both sides by what? R squared. We are making change the subject. We are trying to make change the subject. Is that not it? So Jm1 m2 over R squared times R squared. What happens here? The R squares cancel. We get FR squared on the left hand side equals Jm1 m2. And what do you do to get chain? You divide both sides by what? M1, M2, M1, M2. And our chain eventually becomes what? FR squared over M1, M2. So let's try to describe the unit. What is the unit of force? So we are finding the unit of J will give us what? The unit of force, this force is what? Force is in what? Newtons. How about R? R is distance, right? So it's meters, but it's squared. So you square it, meters squared. Then the mass is kilogram. What do you end up getting? Newton meter squared, kilogram what? Squared. You see, it's simple. So that you get what? So what will the unit finally be? So eventually what will be the J? J will be what? Newton meter squared per what? Kilogram squared. Or you can say that Newton meter squared. You get it? Yeah. So that is the unit of G. That is the unit of G. I hope you are following my people. Good. So good. That is what I have done here in the nose. That is what I have done here. And G is constant. The value is 6.67 times 10 exponent negative 11. Yeah. Okay. Now we have a graph of relation between F and M. F and M. When you check the equation, when you check the Newton's law of universal gravitation, we said that F is what? J M M2 over R squared. And we said that F is directly proportional to M1, M2. Now let's say, when the forces increase, when the gravitational force, when the masses increase, the force also increase. So if the force is directly proportional to the masses, then this graph will explain it. What is the meaning of this graph? This graph also means that when F is increasing, M is increasing. Let's look at this. I'm doing the graduation on the graph. 1, 2, 3, 4. Let's have here 1, let's have here 2, 3, then 4. 1, 2, 3, 4. If I have 1 M, what is my F? If I have 2 M, what is my F? Let me increase M. F also increase. Let me extend this line. If I have 3 M, what is my F? F has also increased. If I have 4 M, what is my F? F has also increased. So here I'm getting around 3 point something, and here I'm getting what? 4 point something. Indeed, so M increase here, F increase, because equation is F is directly proportional to what? M1, M2. So this graph explains it. Is that clear? All right. Then let's look at the graph of relation. I had a PDF, but I unfortunately deleted it. So let me write a graph of relation between the graph of relation between gravitational force F gravitational force F and distance of separation R. How do you represent this? This is represented by this. This is F. This is R. This is the relation. What is the meaning of this graph? This graph tells you that when F is increasing, R is decreasing, and vice versa. Once I already equation, I say F is inversely proportional to 1 over R squared. The farther the particles are separated, the weaker the gravitational force. So this graph explains it. Well, let's say you have here to be 1, 2, 3, 4, 5. Here 1, 2, 3, 4, 5. Let's look at something here. We have 1, 2, 3, 4, 5. When our R is 1, what will happen to F? F is around 2, isn't it? Now let me increase R to 2. I've increased R. What has happened to my F? F is 1 point something. What was F is what? But me increase R. Me increase R about 3. What was F is what? About 0.9 or 1. But me increase him 4. What is what? As this one increases, this one decreases. Yes. So this is the graph of relation between F and R. All right. Let's continue. All right. This is F, and this is R. I have not done anything. I'm just redrawing what I cleaned. It had made Basa, so I was cleaning it. Just redrawing. Right. Good. So that is that. Let us move on then to the next item. Now let's pick a question on the Newton's law of universal gravitation and solve. We talked about the law in our lesson 1. Today we have looked at the mathematical expression. We need to pick a question on it and solve. No, my body is misbehaving. A minute, please. All right. I have a nice question here. This is, let's make this 3.71 kilograms. Okay. All